Okay, let's talk about one of the most paradoxical chemicals on the planet, ammonia. It's this weird thing, right? It's both a hero and a villain in our modern story. It's a cornerstone of life as we know it, but man, it's also a massive environmental headache.
So that brings us to this huge question. What if the very same chemical that let us feed billions of people could be totally reinvented to power our future, to solve our modern energy crisis? Well, that's exactly the incredible story we're diving into.
But look, before we get to the future, we have to understand just how insanely important ammonia is right now. It's this unseen giant propping up our entire modern civilization.
And when you look at where it all goes, it's kind of mind-blowing. A whopping 88%, almost all of it, goes into one thing: fertilizer. Yeah, the food on your plate, it's there because of industrial ammonia. Simple as that. That other little slice, about 12%, that's for stuff like plastics, explosives, fibers, industrial things. But agriculture, it's the king, no question.
And you really can't overstate the impact of this. Just think about it for a second. Our world of over 8 billion people, it literally could not exist without this one chemical breakthrough. We're talking about one of the most important technological leaps in the history of humankind, for real.
So where did this chemical miracle even come from? Well, believe it or not, it was born out of a massive crisis. Back in the early 1900s, the world was literally running out of fertilizer. We needed a new way to feed our crops, and we needed it fast.
The solution came from these two absolute geniuses. First, in 1909, you have the chemist Fritz Haber. He's the guy who cracked the code in the lab. But a lab discovery is one thing. Turning it into a massive world-feeding industrial process, that took an engineer, Carl Bosch. He's the one who scaled it up, and by 1913, it was a reality. And yeah, you better believe they both won Nobel Prizes for it. This was world-changing stuff. So what is this Haber-Bosch process anyway? Well, in a nutshell, it takes the super abundant nitrogen from the air all around us, which is really lazy stuff, it doesn't like to react, and it smashes it together with hydrogen. It's like a forced chemical marriage. And the secret sauce to make it all happen? An iron catalyst and just absolutely insane amounts of heat and pressure.
It's really like a high-stakes industrial recipe. Step 1, you grab some hydrogen, and we'll get back to where that comes from, but it's usually from natural gas. Step 2, you pull nitrogen right out of the air. Then you just squeeze them hard. We're talking 150 to 300 times the pressure you're feeling right now. And you cook them at crazy high temperatures over that iron catalyst. What pops out the other end? Liquid ammonia. It's a brutal, energy-hungry process.
And that incredible energy demand, that's where our story takes a much darker turn. See, this miracle that fed the world, it came with a pretty nasty hidden cost for the environment.
Just get your head around this number. This one single industrial process, Haber-Bosch, eats up between 1 and 2% of the world's entire annual energy supply. That is just staggering. And almost all of that energy? Yep, it comes from fossil fuels.
And here's the real kicker. Remember that hydrogen I mentioned? Well, the main way we get it is by ripping it out of natural gas. And when you do that, what's left over? A whole lot of CO2. And that CO2 just gets pumped straight into the atmosphere. That's the dirty secret. Okay, but what if we could completely change the recipe? What if we could keep the magic of ammonia, but get rid of all that pollution? Well, this is the super exciting idea behind green ammonia, turning this massive polluter into a powerhouse for the future. Let's break down the difference between the old way and the new way, because it's like night and day. The old stuff, gray ammonia, uses natural gas and pumps out CO2. The new stuff, green ammonia, is totally different. Instead of natural gas, you use clean, renewable electricity, like from wind or solar to split water into hydrogen and oxygen. The nitrogen still comes from the air, that part's easy. But the result? You get ammonia with zero carbon emissions. And now it's not just a fertilizer, it's a clean fuel. And listen, this isn't just some sci-fi dream, it's actually happening right now. There's a ship out there called the Green Pioneer. Its engines have been modified to run on a mix of ammonia and diesel. And just recently, it actually completed the first ever ammonia fuel transfer in Singapore. It's proof that this can work as a shipping fuel like today. And the potential scale we're talking about here is just enormous. Just to clean up the global shipping industry, just that one sector, an agency called IRENA figures we're going to need 183 million tons of green ammonia every single year. Now, to put that in perspective, that's about how much of All ammonia, the dirty kind included, the entire world makes right now. All right, so the potential is obviously massive. But let's be real, making this switch isn't easy. It throws up a whole new set of massive challenges. We are literally talking about building a brand new global energy infrastructure, pretty much from scratch.
Yeah, you can't just use the old pipes. We're going to need new ships designed for ammonia, new storage tanks, and huge new pipelines. I mean, look at this proposal in Europe, a 550-kilometer pipeline just to get ammonia from the coast into Germany's industrial areas. That's the kind of project we're talking about.
And of course, a huge piece of this puzzle is safety. Engineers are planning these things with safety front and center. For example, a modern ammonia pipeline would be buried way deeper than a gas line, have much thicker walls to handle the pressure, and be packed with advanced sensors. Plus, they'd have these automatic shutdown valves every few kilometers, so if there ever was a leak, you could contain it super fast.
So here's where we land. A century ago, ammonia saved us from a crisis of starvation. It was a miracle. Today, it could be the key to solving our climate crisis. But the big question remains, can we pull off this second revolution? Can we do it the right way, smartly, safely, and without creating a whole new set of problems? The challenge is huge, but you know what? So is the opportunity.